I want to talk to you today about a circle. And I put a little R on my page because I'm using something that you don't have. At least I don't think you have. I used a safety compass first because I wanted to draw a circle. And I drew a circle with my safety compass because it's easier to control on paper than your compass with the point. But I'm going to use the compass with the point as we are doing our class today. But I wanted to talk to you a little bit about the circle. We call this circle P. That's the symbol for circle P. The center of the circle is point P. And PA and PB are line segments, which are radii, and PA is congruent to PB because, I hope I wrote P, because all radii of a circle are congruent. So I'm going to mark them congruent. We use this terminology a lot in our constructions. Also, when you have a part of a circle, like AB, that's called arc AB, and we usually write it this way, AB with a little tiny arc over it. So that's some symbols that we're going to use. Now we want to construct circle 0 congruent to circle P. So I'm going to come over here and I'm going to put a point on my paper and call that 0 or O, circle O. To have the same circle, congruent circles have congruent radii. So I need to measure the radius of PA or PB. Any radii of this circle will do. Radii is plural for radius. So if I put my point at P and I go out to A or B, it should be the same. Now you can see I'm going to have to open up my compass to get it out to any point on the circle. So if I just open it up, then I can check and see. Yes, I went a little too far for B, didn't I? That should be B. That should be A. Still a little too far for A. Now this is where the problem comes in when you try to do congruent circles, is that it's very easy for your compass point to move. So I try to use several thicknesses of paper when I put my point at 0. And I'm going to come up and put my other finger on the top of my compass so I can move this around, hopefully without moving the metal compass point. But you can see already it wants to move a little bit. So I don't get as good a circle as I would like. And this, you can see as I'm coming around, it has somehow moved, hasn't it? But theoretically, circle 0 should be congruent to circle PA if a radii of this circle, call that OT, is congruent. So let's measure and see. All right, this is the measure of OT. This is the measure of PB. Aha, I'm too small. This circle is a little bit smaller than that one. So I did not have my compass open enough. Let's try again for P to B. P to B. Now if I come over here and I do this, you can see that actually my circle should have gone out farther, but not a whole lot farther. And I'm trying to do it with one hand, which is not really easy to do as well, swinging it around to get it back to this point. But having moved it, you can see that the compass is not quite the circle is not as small as it was. It actually is the outside line. Now, so the point T really should have been out here. If we have congruent circles, we will have congruent radii. So circles P is congruent to circle O if and only if, that's what IFF stands for, PA is congruent to OT, or PB, as long as their radii are congruent. Now again, the important part here in terms of constructions is that I have found that if I don't have some very, very thick paper, and this is not very thick, but if I don't have very thick paper to keep my compass point, the sharp compass point in place, it will slide, and so it affects the circles. So these may not appear to be congruent, but I have constructed them to be congruent. We use the idea that all radii of a circle are congruent every time we cut arcs, because we are measuring line segments that way. We measured our radii that way. So it's important that we at least talk about how to construct a circle, because a circle is all of these points that are equidistant from the center. The circle is all of these points out here that is equidistant from the center. Now, I want to show you something with my little piece of compass that I have here. This is the one I was telling you about, that I can draw several circles with. And I think I'll turn my paper over and do it on the other side of the paper so you can see better what I'm talking about. Because something else that we notice about circles is that we can have concentric circles. So it's very easy to hold this in place with my finger, and this swivels very nicely. I can get a center point this way, and then I just simply have to hold down the plastic piece in the center. And I can choose any measurement I want to, and I can go around and I can draw a circle. Now, my problem is right now that I'm running into something on the back side. That's okay. In a moment, I'll slide my paper and I'll take care of that. But what I'm wanting you to see is that using the same center, I could choose a different measure and get another circle that has the same center. Get my pencil point down in here. Right here so you can. Now, I want to slide my paper just a tad. So hopefully I can go all the way around. Making sure that I have the same that I had before. Because if I didn't, what's going to happen? If I have moved it, what's going to happen now? What do you notice about these circles? These are concentric circles. This was my original circle all the way around. Original circles. Are you beginning to notice something here? All of these circles have the same center, but what has changed is the radius. All of the circles that I have just drawn have the same center point right here, but the radius for this inside circle is obviously a smaller line segment than the radius for the next circle, which is obviously a smaller line segment than for the next circle. which is obviously smaller than for the next circle. But when you have circles with the same center but different radii, these are called concentric circles. You'll talk about those later this year, but I figured while I had my safety compass out, it would be a good time to show that to you. And the safety compass it's no big deal. The advantage to it is it doesn't need that sharp point. And so therefore I didn't have to worry about it moving so much on the paper. So I could keep the same center every time. Where if I am using the engineer's compass, I sometimes have a little difficulty with that. So I wanted to go back and review circles with you because we use this in all of our constructions. Have a blessed day.